Hello everyone. On this video we will be going over systems of linear equations with just a few example of story problems. Okay, so I'm assuming you've watched and practiced all of the systems of linear equations video as far as elimination and substitution in order to solve. So this is just applying those to actual story problems. Okay, so here are a few steps to kind of help you get going. Okay, first you want to note that in some instances, either rereading or drawing a picture of the problem may help you understand exactly what you're solving for. Okay, sometimes it's not clear, so reading it a second or third time or drawing a little diagram sometimes helps. Okay, so your first step, you want to choose variables to represent your unknowns. Okay, it could be X and Y, it could be L and T, it could be any variables at all, as long as you know what variables represent what unknown. Okay, then once you do that, you want to translate your problem into two equations and then solve, but that's only if it's necessary. Some of your questions don't want you to solve, they just want you to create your linear equation model without actually solving it. Okay, so if some of the terms are a little bit unfamiliar or you don't remember them, you can go back to the intro to problem solving video and it will kind of give you a refresher if you need it. Alright, so let's go to our first example. Alright, so for your first example, says the sum of two numbers is negative 110. Okay, and we also know that one number is 10 less than the other. Okay, so they want us to find the numbers. Alright, so remember the first thing you want to do is we want to find variables for our unknown. Okay, so we have two numbers. Both numbers are unknown. So we'll have X equal our first number and Y equal your second number. Okay, so we just assigned a variable. You could have picked X and Y, R and S, doesn't matter at all. Okay, now if you notice, if you go back through your problem, you'll see the sum of two numbers is negative 110. Okay, so we know sum is just another way to say addition. Okay, so we know that the first number, which is X, plus the second number is equal to negative 110. Okay, that's just from that very first sentence. Okay, so that actually gives us our first equation. Okay, now if you look at the second sentence, it said one number is 10 less than the other. Okay, so that means, just for, let me circle that, should have included that. But if we go down to here, just for that one section of the sentence, we can let Y equals X minus 10, because 10 less than the other, that means Y is 10 less than X. So it's equal to X, and then you take 10 away. And this is actually our second equation. Okay, so that gives us, kind of separate that a little bit, the system X plus Y equals negative 110 and Y equals X minus 10. Okay, now the good thing about story problems is they don't tell you what method to use to solve it. So you can choose any one you want to. And since we have a y variable by itself, and there are no large coefficients anywhere, I'm just going to use the substitution method. So I'm going to replace y with x minus 10 in the first equation. And again, if you wanted to, you could subtract x to both sides and then add them together. You can do it that way if you wanted to. You'd still get the same answer. Okay, so we have x plus y equals negative 110. Move that up a little bit. That gives us, replace y with x minus 10, so we have x plus x minus 10 equals negative 110. Okay, so since that's plus, we're basically going to go ahead and drop the parentheses. So we have x plus x minus 10 equals negative 110. Okay, so we can go ahead and add 10 to both sides, where that disappears. And plus, we can go ahead and combine those two while we're at it. So you have x plus x, which is 2x, equals negative 110 plus 10 is negative 100. Move that up a little bit. Okay, so if we divide both sides by 2, we end up with x equals negative 50. Okay, so once we solve for one of the variables, plug into either equation. Move that up a little more to solve for y. Okay, so if we go ahead and plug that in, we can use either equation, either the x plus y or the y equals. Of course, I'm just going to pick the y equals because it's easier. Okay, so y equals x minus 10. So if we plug in x equals negative 50, that's y equals negative 50 minus 10. Okay, so we end up with y equals negative 60. Okay, so your solution, remember it's x comma y, so it's negative 50 comma negative 60. That's if they want it in ordered pair form. Sometimes they just want you to put x equals whatever and y equals whatever. But just in case they want it as an ordered pair, that's how it would look. Alright. So if you're still writing, feel free to press pause, but we're going to go ahead to our next example. Okay, so let's say you have a live show that's performing locally. Okay, so matinee admissions for the show for 4 adults and 2 children is $374, while admission for 2 adults and 3 children is $285. Okay, so what is the price for a single adult ticket and a single child's ticket? Alright. Okay, so first we're going to go ahead and assign variables. So we're going to let C equals the price of a child's ticket. Let me straighten up that K a little bit. Alright, and we'll let A equal the price of an adult ticket. Okay, so now we kind of look at what's described to us. So we have 4 adults and 2 children is $374. Okay, so we have 4 adults and 2 children. We can actually get our equation from that. So we have 4 adults plus 2 children equals 374. Okay, so now you have 2 adults and 3 children. 2 adults and 3 children. That's 2 adults plus 3 children. We know that's 285. Okay, so we have our equation. Okay, so we have 4a plus 2c equals 374. And we have 2a plus 3c is 285. Okay, so we can see there we can't use substitution. But if we use the addition or elimination method, we just have to turn these into opposites, or the c's coefficients into opposites. Easy to do to eliminate the a. So we'll multiply each term by -2. That will make the coefficients opposite. Okay, so if we multiply this by -2, this by -2, and this one by -2, we have -2 times 2, so that's, well, actually first let's write the first one. So we have 4a plus 2c equals 374. So 2 times -2 is -4a. So we have -2 times 3 minus 6c equals -2 times 285, which is -570. Okay, so now we have opposites, so we go to our third step, which is to add them together. Okay, and if you're a little unsure of the steps, you can go back to either solving by elimination or substitution, depending on the problem, and it'll go through all of the steps again. Okay, so you have 4a minus 4a is 0, so that cancels out just like we planned it. Okay, so you have 2c minus 6c is -4c equals 374 plus -570 is -196. Okay, so we have -196. There we go. So -4c equals -196. So if we divide both sides by -4, we end up with c equals 49. Okay. So once again, once you solve for one of the variables, you plug into either equation to solve for a. Alright, so let me kind of separate this a little bit since we're running out of space. So we have 4a plus 2c equals 374. Okay, so if we plug in c equals 49, we have 4a plus 2 times 49 equals 374. Okay, so 2 times 49 is 98. So we have 4a plus 98 equals 374. So if we subtract 98 from both sides, and I'll just continue this over here since we're a little low on space, that gives us 4a equals 374, clean that up, minus 98 is 276. So if we divide both sides by 4, we end up with A equals 69. Okay, so we know that the price of a child's ticket is $49 and the price of an adult ticket is $69, just based off the information they gave us in the problem. Alright, so let's go ahead and do one more example. Alright, so one car dealer pays its employees a salary of $10,000 plus a commission of $1,000 for each car sold. A second dealer pays a salary of $20,000 plus a commission of $500 for each car sold. How many cars would need to be sold to make the total pay the same? Okay, so we want to know how many cars would have to be sold for the employee from the first car dealer and the second car dealer to make the same amount of money. Okay. Now the thing with this one is there's only one number of cars that you would sell. So you don't have to go X and Y. X is equal to this, Y is equal to that. We're just going to let X equals the number of cars sold. Okay, we don't need to know how many are sold at the first one or the second one, because they're just asking how many would need to be sold at both for them to make the same amount. So X would be the same number at both for this particular problem. Okay, now we know that the pay at each dealer is equal to your base salary. Remember, it's $10,000 at the first one and $20,000 at the second one, plus your commission. Okay, so both of them pays the same way. Okay, so if we look just at that model, we can see that the pay at the first dealership is equal to $10,000. Remember, that's your base salary plus the commission. So if they get $1,000 for each car, that's $1,000 times the number of cars they sell. So if they sell one car, it's 1,000 times 1. If they sell 2 cars, it's 1,000 times 2. So they get that $10,000 no matter what. But they just keep adding on $1,000 for each car they sell. Okay. Now remember, that's the first dealer. Now the second dealer, the pay will be equal to $20,000 plus 500 times the number of cars that are sold. Okay, so that's your second dealer. Okay, now since we want to know what value of X would make these two the same, we basically are trying to figure out what will make this equal this. Okay, let me write that out. So since we want to know what value of X would make the pay the same, solve for, that's 10,000 plus 1,000 X, so slide that up a little bit, is equal to 20,000. plus 500x. Okay, because somewhere out there, there's a value of x that would make the first dealer pay equal to the second dealer pay. Okay, so this is an instance where if you set it up like this as your first equation and second equation, you don't have to solve it using elimination or anything else. You can say p plus p is 2p and go through all that, but it would be a little more confusing. It would be easier when they're asking what would make it the same to just write it out like this and then solve for x. And just completely bypass all of the substitution and elimination steps. Okay, so if we subtract 500x from both sides, where that cancels out, so we now have 10,000 plus 1,000 minus 500 is 500x equals 20,000. Okay, so now we go ahead and subtract 10,000 from both sides. Go ahead and subtract 10,000 where that cancels out. And that leaves us with 500x equals 10,000. So if we divide both sides by 500, we end up with x equals 20. Okay, so you would have to sell 20 cars at either dealership for the pay to be the same. Alright, so hopefully this made sense, because there are plenty of different types of story problems. So the most I can do is show you an approach. I can't do an example of every story problem you'll ever run across, but hopefully this approach makes sense to you. Okay, so I will see you on the next video.